Hello. Yes, Nana. Right, Ra. So last class what we were doing, Nana? In electrophilic addition reactions, right? I gave you some questions, right? So now we'll discuss those questions one by one. The people who already did, just cross check, okay? Right, Ra. So the first question which I gave you, so electrophilic addition reactions we are discussing, right? Electrophilic addition reactions. So yesterday I explained, right? So here CH2H, CH2Br. So this yesterday we discussed this, right? So HBr undergoes heterolytic cleavage, H plus plus Br minus. This is acts as electrophile, electrophilic addition reaction. Electrophile is initiating CH2 double bond, CH2 plus H plus is coming and attacking over here because symmetrical alkene. Alkenes are two types, symmetrical and unsymmetrical cases. That doesn't matter. So for example, if I'm adding the left side, you get the carbocation. So this Br minus is coming and attacking CH2H, CH2Br. Okay, this is exactly which is taking place. Last class we discussed. I gave you some questions, right? CH3, CH3 double bond CH2 plus HBr. Now, what exactly happens? First H plus plus Br minus is coming, right? The electrophile H plus is attacking over here. So CH3, CH3 double bond CH2. The first H plus, the H plus is attacking here. So if the H plus attacking over here, carbocation is forming here, right? So CH3, CH3, positive charge CH2, H, nothing but this is which carbocation? 3 degree, tertiary carbocation. If H plus is attacks over here, we will get primary carbocation. Last class I told you, carbocation 3 degrees greater than 2 degree, 1 degree. Right, Nana? So then Br minus is coming and attacking over here. CH3, CH3, Br, CH3. This is a final product. Write it down. Sandra? Next example. This is very important example. So first what exactly happens in this mechanism is very important. HBr undergoes H plus plus Br minus Next, CH3, CH3, H, CH double bond CH2. The first H plus is coming and attacking particularly here. Why? If the H plus is attacking, we'll get the carbocation 2 degree carbocation. If it attacks here, 1 degree carbocation is forming, right? So here only I am writing the product. CH3, CH, CH3, CH, positive charge, 2 degree carbocation is forming here, right? 2 degree carbocation. Then here is rearrangement is takes place now. This carbon is 3 degree carbon, right? The hydrogen I am writing like this. Hydride shift is takes place. Why hydride shift? It gives, I told you yesterday, this is which we have a 2 degree carbocation, this is 3 degree carbocation, right? 3 degree carbocation. So whenever the adjacent carbon is more stable, carbocation is there, by default carbocation rearrangement is takes place. So then Br minus is attacking over here, CH3, CH3, Br, CH2, CH3. This is the major product. ఇది రాసాను, రీఅరేంజ్మెంట్ చేసావా? So natural tendency of rearrangement right here. Always remember I told you, so 2 degree, if adjacent 3 degree is there, by default rearrangement is takes place to get the stable carbocation. అంశని రాసావా? ఇది ఇదే ప్రోడక్ట్ వచ్చిందా? కోన నువ్వు రాసావా? డేనా వేగన ఫాస్ట్ రాయాలి. వెళ్ళావా ఈరోజు? డేనా అయిపోయిందా? Next question, same methyl shift is taking place now. So in this case, what exactly happens? Right, first H plus, directly I am writing H plus plus Br minus H plus coming and attacking over here, we'll get the carbocation over here, right? So first CH3, 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 CH plus CH2H. This is 2-degree carbocation. Now, if we are doing the methyl shift here, this a methyl shift, so it becomes 3-degree carbocation. So means CH3, CH3 carbocation. So రాసేస్తా ఉండండి ఇలా simultaneously, right? So then Br minus is coming and attacking over here, CH3, CH3, Br, HCH3, write it down. సేమ్ అంతకుముందు అలానే కాపీ చేయండి. ఇక్కడ హైడ్రోజన్ ఉంది, హైడ్రోజన్ ప్లస్లో మిథైల్ పెట్టేస్తాం. దాంట్లోంచి కాపీ చేసుకో సేమ్. ఓకేనా? సో నాకు క్లియర్ ఉందా వంశిని? Done? Next. I gave the question like this. Right. So first H plus is coming and attack side, particularly down, because we'll get the tertiary carbocation. So the first step, what we will get? Here is the carbocation, here is the hydrogen. Next, Br minus, here we will get the product. Write it down. And the other example also same like this, right? Try first, try. ఎంతమంది? When carbocation present on the ring expansion is won't takes place. When it is outside, then only ring expansion is takes place. The next example which I gave the ring expansion, that is important. Then next one. This is what important. Okay. So first H plus is attacking here, where H plus attacks in the this carbon, right? We'll get the secondary carbocation. If the H plus attacks here, we'll get primary carbocation. So already we know here is the carbocation, we'll get like this. Next, no? So particularly, we should know that cyclopropane, cyclobutane, cyclopentane, and cyclohexane. So generally, cyclohexane is more stable. Cyclopropane, cyclobutane, cyclopentane, cyclohexane. In this case, cyclohexane is more stable. Cyclohexane is more stable because it is in chair form, so less repulsions are there. So whenever the outside carbon is having the positive charge, ring expansion is takes place. This 5-membered ring will become 6-membered ring to get the stability. So the ring expansion, it's simply a number game, right? A lot of people are confusing this. So the ring expansion, simply it's a number game. Just give the numbering like this: 1, 2, 3, 4, 5, 6 from carbocation onwards. So imagine the 2 and 6 bond is undergoing heterolytic cleavage. This 6 is going to attack at the first carbon. At second carbon, which charge we are getting? Positive charge, right? So directly, so for example, the bond is, imagine the breaking is like this. So actually, this is just intermediate step. For understanding purpose, I am telling. Right, the 6 is going to attack the first position. So blindly write 6-membered ring. Okay, so then give the numbering as your wish. Now the new bond which is formed between 1 and 6. This is 1, 6. At first position, what is there? One methyl group. This one. One methyl group. Second position, we are having the carbocation. Now first position is which degree carbon? Right? 3-degree carbon is there. Here is hydrogen is there. Hydride shift is takes place. Hydride shift. Why hydride shift is takes place? To get the stable carbocation. This is 2-degree carbocation. No? This is 3-degree carbocation. Next, what exactly happens? Br minus is coming and attacking over here. Right? This is the final product. Write it down. Any doubts, you can ask me. రింగ్ ఎక్స్పాన్షన్ చేసాను, వచ్చిందా? సేమ్ వచ్చిందా ప్రోడక్ట్? ఇంతకుముందు చెప్పాను అనేవి ఇక్కడ ఎప్పుడు అందుకోసం ఫాస్ట్ చేసేస్తాను. ఇప్పుడు ఈజీగా ఉన్నాయి కదా సెకండ్ టైం ఏంటంటే ఈజీగా ఉన్నాయి కదా. If the positive charge present on the ring expansion is won't takes place. Just outside only ring expansion is takes place. Then అర్థమవుతుందా? Same example which I gave you. HBr. Simply same like that. I am directly writing the product. Cyclobutane will become cyclopentane. Same. Try this one more time. Try this now. అవసరం లేదు, అదే మెకానిజం రాసేయండి, కరెక్ట్ సరిపోతుంది. So first what exactly happens? H plus is attacking it here. We'll get the secondary carbocation. So then same, it's a number game. What exactly the number game? So 1, 2, 3, 4, 5. So directly bond breaking with 2 and 5 position. So directly write the 5-member ring 1, 2, 3, 4, 5. The new bond which is formed between 1 and 5. At the first position methyl group is there, at second position carbocation, right? Simply rearrangement hydride shift takes place. Stable carbocation, then Br minus is attacking, get the product. Write it down. Same as it is. है ना? Right? It is nothing but CH2, Nana. So this is the product we will. First H plus is coming and attacking. H plus Br minus, H plus attacking over here. So we'll get the carbocation. So there Br minus. Write it down. है ना? For example, if I are taking the alkyne HBr, right? What exactly happens? Same thing. HBr undergoes H plus plus Br minus. So in case of alkynes, I told you in electrophilic addition reaction, alkenes are more reactive than alkynes. Write it down. In electrophilic addition reaction, in electrophilic addition reaction, in electrophilic addition reaction, alkenes are more reactive than alkynes. Important point. Of course, this is symmetrical alkyne. So for example, if H plus I am attacking over here, what we will get? CH double bond CH H positive charge. So then Br minus is attacking over here. Here where the positive charge? Br CH2, right, double bond. Next to one more, like it acts as an alkene, right? Now what exactly happens? One more time, H plus. This H plus coming and attacking particularly here. So CH Br positive charge CH2 H. Why only here? Why not here? The H plus is attacking here. Why not this carbon? Anyone? This carbocation is stabilized by the resonance. Okay, more stable carbocation. That is the reason. Br minus attacking CH, Br, Br, CH3. Come on, write it down. రామానుజం ఎగ్జామ్ ఎప్పుడు ఉంది నీకు? డన్. హెచ్ ప్లస్ ఇక్కడే అటాక్ ఎందుకు అవ్వాలి, ఇక్కడ ఎందుకు అటాక్ అవ్వకూడదు అంటే చెప్పాను కదా, ఈ కార్బోకేటే అనేది మోర్ స్టేబుల్. ఎందుకు? బికాస్ ఆఫ్ రెసొనెన్స్ స్టెబిలైజ్డ్. సో బీఆర్ ఏం చేస్తుంది? సో మీకు డౌట్ రావచ్చు, సార్ అకార్డింగ్ టు ఇండక్టివ్ ఎఫెక్ట్ అయితే ఇది మోర్ ఎలక్ట్రోనెగటివ్ కదా, లాగేసుకుంటుంది కదా మోర్, మరి అప్పుడు అన్స్టేబుల్ అవుతుంది కదా కార్బోకేటైన్ బికాస్ ఆఫ్ రెసొనెన్స్ వల్ల. సో హలో, ఎస్, యా. హలో, డన్. ఫర్ ఎగ్జాంపుల్ CH3C triple bond CH plus HBr. Write the product. Write the products. Right or wrong doesn't matter. Write it down. యూట్యూబ్లో సౌండ్ వస్తుంది. సౌండ్ ఇప్పుడు నేను మధ్యలో మైక్ తీసాను, కాల్ వచ్చిన. First H plus is attacking here itself. Okay, we'll get the carbocation CH3. Here is the positive charge, double bond CH H. So then what exactly happens, Nana? So Br minus attacking over here, where the carbocation CH3 C Br double bond CH2. This is the first step. So one more double bond is there, right? So CH3, here is the Br double bond CH2, once again H plus. I told you the H plus will attacks here itself because the carbocation which is getting more stabilized by the resonance. This is the carbocation. Here is CH3 directly, CH2 and H. So Vr minus CH3, Er, Vr, CH. 2,2 dibromopropane. Write it down. 2,2 dibromopropane. So this reaction which is coming in second year also, the preparation of haloalkanes. Alkyne chapter 1, 2 moles. Then నేను అక్కడ కూర్చొని చెప్పేటప్పుడు ఉన్నావు కదా బిగినింగ్లో అట్లా బాగుంది అలా కూర్చొని కొంచెం లైవ్ ఫీలింగ్ వస్తుంది. నెక్స్ట్ దిస్ ఈజ్ ఇంపార్టెంట్. HBr 1 mole. Only 1 mole is giving. So where it is attacks? Alkene and alkyne. Alkene, because I told you alkenes are more reactive than alkyne. So CH2, H, CH, Br, CH2, C triple bond, H. Write it down. And this is one more important question. CH2 double bond CH, C triple bond CH, plus HBr. There is also 1 mole. Now write the product, this one. Write it down. Now the HBr attacks at alkene or alkyne. If it is attacks at alkyne, Hamsini. So where this HBr will attack? Here or here? Double bond or triple bond? Resonance లో ఉండదు, అయిన తర్వాత resonance double bond. So in this case, exception case, no, it is attacks at triple bond, because after getting the product, what exactly conjugate double bonds are coming. when the conjugate double bonds are more resonance stabilized. So that's the reason, even though alkenes are more reactive than alkynes, but in this case the reaction takes place like this. Put 5 step. If excess is giving, so reaction takes place in all positions, but clearly we are mentioning that, so limited number of 1 mole of HBr. Then any doubt here? Next, no. Same alkenes when treating with water, H2O, trains of acidic medium. Acidic medium, electrophilic addition reaction takes place. We'll get the product CH2H, CH2OH. Same like HBr, where the Br is attacking, at the same position OH is attacking, but the mechanism is bit different, but everything is same. Generally we used to take H3O plus, no. H3O plus is H plus plus H2O. This is electrophile, that is water is nucleophile. So now the first step same as it is. First H plus is coming and attacking over here. So according to that product I told you, CH2H, CH2, positive charge. So then water is coming and attacking as a nucleophile, H2O. What exactly happens, Nana? CH2H, CH2OH, H, positive charge. So in the last step, what exactly happens? Taking this one, H plus is going out, minus H plus, CH2H, CH2OH. Write the product. Actually directly we can write OH, H plus. If you are taking the water, H plus OH minus, but this is a NCERT type of mechanism. So water is somewhat weak, right, nucleophile when we compare with the OH. Right, write it down. Imra, where is here also we are getting the carbocation and carbocation rearrangement takes place, and ring expansion takes place, and everything, whatever the reactions with the alkene with HBr we did, the same thing is happening here also. So as a homework all these questions, Same Nana. Same as it is. In these two cases, ring expansion is takes place. Write it down. Right, completed. Hello. Hello. Completed. Same as it is, I told you. What would be the products? Hmm? Here is the OH. Directly I'm writing the products. If you have any doubts, let me know. Here is here the OH is coming. In this case, methyl shift is takes place. In this case, OH is here. OH. So let me know which number you want. I'll explain that. Write the products. If anything if you want, I'll explain. రామానుజం ఎగ్జామ్ ఎప్పుడు ఉంది నీకు? 23rd. ఎక్కడ పడింది సెంటర్? మల్కాజ్గిరిలో ఎక్కడ? మల్కాజ్గిరిలోనా లేకపోతే అల్వాలా? మల్కాజ్గిరిలో ఉందా? చదువు ఒకసారి సెంటర్ పేరు. కంపెనీ ఓకే ఓకే. మౌలాలి అదే నువ్వు మల్కాజ్గిరి అంటే నేను సరేనా? నెక్స్ట్ నానా put the heading free radical addition reaction. Free radical addition reaction. Trains of peroxide. So sera without peroxide, peroxide without peroxide. Two reactions are there. For example, if they are giving without peroxide, that is electrophilic addition reaction. Hello. Only HBr. We are giving the HBr with peroxide. Peroxide. So here I am writing the major product. Already we discussed 2-bromopropane is the major product. But whereas in this case, this is the major product. Here it is major product. So minor product both the case opposite. This is minor. Here is this minor. Write it down. Hello. Ah. Salim. So above one, which reaction? I told you, right? Which one? Above one. Hello. The first one is without peroxide is electrophilic addition reaction. This is free radical addition reaction. What exactly the mechanism we'll discuss, okay? So in free radical addition mechanism, first I'm just giving the question like this. Of course, already I gave you HBr. So peroxide. So generally we used to take benzyl peroxide, no? What exactly the benzyl peroxide is like this. C double bond O, C double bond O, like this. This is benzyl peroxide. In the benzyl peroxide, what exactly happens? Homolytic cleavage takes place. C double bond O radical plus O radical, C double bond O. 2 moles actually it's getting, so the center homolytic cleavage takes place. So once again right here is homolytic cleavage, once again it takes place. We'll get phenyl radical and this radical will go to CO2, carbon dioxide. How the carbon dioxide is forming? C double bond O, already O radical here, right? So here from one radical, both are touching, CO2 is forming. So now the last step, so this here HBr is coming, H is attacking to benzene ring and Br radical is coming out and benzene is going out, right? Now Br is the reagent which is attacking actually. The total whatever we did to generate the Br radical. Br radical is a free radical. So free radical addition reaction takes place. CH3, CH double bond CH2, Br radical. This Br radical, where it is attacking? Let me know now. The first position, second position, where it is attacking. So if it is attacks the first position, is homolytic cleavage takes place. Two radicals are coming, this radical, right? So if it is attacks the first position, CH3, CH radical we will get here CH2, Br. And if it is attacks at second position, CH3, CH, Br, CH2 radical. Now let me know carbon free radicals now. So 3 degree is greater than 2 degree, 1 degree. Tertiary is more stable than secondary, primary. Same like carbocation. In this case, this is which carbocation? 2 degree. This is 1 degree. Which is more stable? 2 degree. So means Br is majorly attacks at the first position. So then afterwards what exactly happens? Hello. So once again HBr is coming attacking over here. So CH3, CH2, CH2, Br, this is a major product, this is minor product. This is major because based on carbon free radical stability, nothing is there. Carbon free radical stability. H is and Br radical is going out, right, as a byproduct. Write it down. Otherwise, I'll tell you one small logic. Even if you want to take H2O2, H2O2 means what? It undergoes homolytic cleavage, OH radical, 2 moles. This OH radical with HBr, one is H2O with Br radical. This Br radical is attacking alkene in the first position. Okay, like that. This is a shortcut method. This is actually in the NCRT they gave this benzyl peroxide, that's the reason. So we used to do. Otherwise in competition examinations we can use. The main electrophilic addition and free radical addition, what is the main difference? There is H plus is attacking, here is Br radical. ఇక్కడ నేను ఒక స్టెప్ చెప్తాను దేనికి ఎలక్ట్రోఫిలిక్ ఎడిషన్కి CH 3CH double bond CH2. Here is H plus is coming and attacking, right? H plus is attacking over here. We get the stable carbocation. This is electrophilic addition reaction. This is free radical addition reaction. That main difference you can see here, these two reactions. In free radical addition reaction, Br radical is attacking simply. In electrophilic addition reaction, H plus is attacking. And the product which is determined by the stability of carbo intermediate. In this case, carbocation is forming, and there is carbon free radical. And one more important thing is carbon free radical, no rearrangements, because it's an endothermic reaction. Carbon free radical does not undergo which one? No rearrangements and no ring expansion. Only in case of carbocation cases only ring expansion is takes place and rearrangement takes place. Okay, now write it down. రామానుజం ఎట్లా ప్రిపేర్ అవుతున్నావు మరి? Done? Any doubt now? Any doubt? Anybody? So node pet రాసుకుంటారా in carbon free radical and free radical addition. In free radical addition, no rearrangements, no ring expansion. No rearrangements, no ring expansion. Done? Completed? So write the questions. Peroxide. The 11, it's not 11, it's a peroxide, okay? Write it down. నందన అర్థమవుతున్నాయా? నిన్న రాలేదు? అచ్చా. అది వాళ్ళకు ఎగ్జామ్స్ అవుతున్నాయి కదా, ఒక 2-3 డేస్ 8 o'clock ఉండదు. Dana? So did you write the products now? Here is the bromine. So let me know any doubt. These are the products. Let me know any doubt. Okay, na? So remaining will continue tomorrow.